Good evening, all of you. Myself, Harish Kanati. I am the PMRF fellow at IIT Roorkee. Today, we are going to solve that assignment 10 questions of the basic electrical circuit. The course instructor, Professor Ankush Sharma. The first question is: in a balanced three-phase star system, the source is an ABC sequence of voltage VAN equal to 100 at an angle of 20 degrees. The line impedance per phase is ABC sequence. It means a ABC sequence. It is VA, VB, VC, and that VAN is 100 at an angle of 20 degrees. Means 100 at an angle of 20 degrees. This is 20 degrees, like 120 degree line, right? So we can write 100 at an angle of minus 100 degrees. This will be 100 at an angle of minus 220 degrees. Why? Because here it is a balanced three-phase system, and the line impedance per phase is 0.6 plus J1.2 ohm, and the load impedance. Sorry, we can write line. Yeah, load impedance, jet load. Okay, jet load impedance is 10 plus J14. It means a star system. The circuit is like this. It is Z line, and here it is a star load. Okay, it is Z line, it is Z load. Okay, here it is VA, VB, and VC. Then calculate the voltage across the load connected to the phase C. It means we have to calculate the voltage across the phase C. Let us suppose this one is phase C. We have to calculate voltage across this point VC. Let us suppose it's VCL load. Okay, how can we find out? This is Z load, this is Z line. Okay, right here the voltage is 0 volts, right? It is balanced source and it is balanced load. Here the voltage is 0. We can find out the voltage across this load ZL by applying voltage divide rule, right? It means, how can we write voltage divide rule? The voltage divide rule, VCL, voltage across the load CL, equal to total voltage. The total voltage is C phase voltage into impedance of that load, that is Z load, by total impedance, right? That is Z line plus Z load. So here we can add one more piece. Yeah, here VC equal to 100 at an angle of minus 220 degrees. Z load equal to, what is the given? Z load equal to 10 plus J14, right? It is 10 plus J14 by, what is Z line? Z line equal to 0.6 plus J1.2. 0.6 plus J1.2 plus 10 plus J14, right? Z line plus ZC is equal to 100 at an angle of minus 220 degrees 10 plus j14 by 10.6. 10. By adding these two real terms, it is 10.6, and two imaginary terms, it is plus j 15.2. What is the value? It is VCL equal to, we can use calculator, it is 100 at an angle of minus 220 degrees into 10 plus 10 plus 14j, yeah, 14i or 14j, 10 plus 14i divided by 10.6 plus 15.2i, which equal to 0.9284 at an angle of minus 0.6469 into 100 at an angle of minus 220 degrees, which equal to 92.84 at an angle of 139.35 volts. This is the voltage across the load C, which is 92.84 at an angle of 139.35, right? This is option C. I hope this question is clear. Moving to the next question. So next question. Obtain the magnitude of the line current for the figure shown below. It means we have to find out the magnitude of the line current. It means we have to find out some only magnitude. Okay. So this is Z load is connected in delta. We can transfer delta to star, right? It means Z load is connected in a delta, that is connected in delta. We can convert into star. What is the equivalent? Here all the impedances are equal. What is the star equivalent? It is simply Z delta by 3, right? So what is the impedance of Z star? 12 plus J12 by 3 equal to 4 plus J4. It means this circuit is same as the previous circuit. Okay, this is Z star, Z star, Z star, and this is Z line equal to 1 plus J2 ohm. What we need? We need the current flowing through this particular line. So here the voltage is 100 at an angle of 0 degrees. Here this source is balanced and load is balanced. So we can simply find I line equal to, from Ohm's law we can find voltage across the impedances plus total impedances. What is the total impedance? It is Z line 1 plus J2 ohm plus Z star. Z star is 4 plus J4, right? Equal to 4 plus J4, which equal to 100 at an angle of 0 by 4 5 plus J700. sorry, J6. J6 ohm. What is the equivalent of 100 by 5 plus 6J is equal to 12.80 at an angle of minus 50.19 degree amperes. However, here we need only the magnitude. So, I line magnitude equal to only 12.80 amperes, which is option A. First, we converted delta impedance to its star equivalent impedance. Then we applied one KVL in this particular loop, or we can apply Ohm's law simply. It is the total this much voltage is applied across this line impedance and the Z star impedance. So we can find out that I equal to total voltage 100 at an angle of 0 by total line impedance by star equivalent impedance. So here only ask the magnitude. So that is only 12.80 amperes. I hope this question is clear. We are moving to the next question. Next question is, find the IC in the figure shown below. Z, Z delta equal to 12 minus J15 ohm. Z star equal to 4 plus J6 ohm. So first we will convert that outer delta into its star equivalent. So what is the star equivalent? It is simply Z delta by 3. Why? Because all the impedances are equal in magnitude and connected in delta fashion. Its star equivalent will be Z delta by 3 ohm. Z delta equal to 12 minus J15 by 3, which equal to 4 minus J5 ohm. It means this, yeah, this is Z star, previous one. Yeah, just a minute. Copy, paste. Can remove this picture. We'll give some other different color. And okay. This Z, this one is Z1. Let us suppose 1. It means we converted this as a 1. Okay. It means this Z5 and Z5 dash are connected in parallel, right? Why? Because this point, let us suppose A, this is also A, and this is also A. Similarly, this is B, and this is also B, and same as this is also C, and C point. It means all these impedances are connected in parallel. So what is the equivalent? Equivalent is Z5 and Z5 dash are connected in parallel. Equivalent impedance is Z5 into Z5 dash by Z5 plus Z5 dash, right? Simply it's parallel. So Z equal to 4 plus J6 ohm 4 plus j6 ohm. Z by dash equal to, just we calculated, 4 minus j5 ohm, 4 minus j5 ohm by total 4 plus j6 ohm plus 4 minus j5 ohm, which equal to 4 plus 6j into 4 minus 5j divided by 4 plus 6j plus 4 minus 5j, which equal to 5.2, sorry, 5.772 minus 0.21j ohm, which is equivalent. However, here the source is connected in delta. We have to convert into the star, right? It means here these are line voltages. We have to convert into delta. However, there are three voltages which are, let us suppose this is R phase voltage and this is Y phase voltage and this is B phase voltage. Okay, R by B or A B C. Okay, what is the line voltage VR by? VR by is VR minus VY, right? It means VR, let us suppose this is minus VY, this is minus VR, this is minus VB. VR minus VRY means VR minus VY. Addition of these two, right? It is approximately at some point it is VRY. What is the angle? This angle? This angle is 120 degrees. So this angle will be 60 degrees and this angle will be 30 degrees, right? It means the phase voltage VR lags the line voltage by 30 degrees. So VRY is the line voltage, VR is the phase voltage, lags by an angle of 30 degrees. So to convert these voltage sources into phase voltages, we have to divide it by root 3, means VA or VR 440 by root 3 lagging angle minus 30 degrees, right? Which equal to 440 by root 3, which is of 254 at an angle of, sorry, 254.034 at an angle of minus 30 degrees. This is VA. Similarly, it is a balanced, right? So VB equal to 254.034 at an angle of minus 120 minus 30. It means minus 150 degrees, right? And VC equal to 254.034 minus 240 minus 30, it is minus 270 degrees. This is voltage volts. What we need? We need IC current. It means now we can redraw the circuit, which is, yeah, we can take it from previous one, right? It is same circuit. Okay, it is also drawn on this figure, so we cannot, yeah, this we can take. Okay, here in the question he given that z line equal to, that is zi equal to zl 2 ohm. It means this resistance is 2 ohm. What about this one? This one we just calculated, which is of 5.72 plus 0.21. This one only, right? Just we calculated from the equivalent. So this is VC. Here the voltage is 0 volts and here it is 0 volts. So we can find this current IC equal to VC by Z line plus Z load. Why? Because these two are connected in series and we can apply KVL like this. Why? Because this potential and this potential at same voltage, same potential terminals, and this neutral. So we can write VC equal to, just we calculated, it is 254.034 at a 254.034 at an angle of minus 270 degrees by Z line, it is 2 ohm plus Z load, it is 5.72 minus 0.21 G, which equal to, yeah, 254 254.034 shift at an angle of minus 270 degrees divided by 2 plus 5.72 minus 0.21, which is equal to 32.93, sorry, 89, 32.8937 at an angle of 91.5581, and this is IC, which is 32.89 at an angle of 91.6. This option A. I hope this question is clear. This question just we solved. First we converted outer delta connected load to its star equivalent, so that its star equivalent comes parallel to this existed star. Okay, so these two stars are connected in parallel, so we calculated its equivalent load, equivalent, that is 5.72 minus j 0.2. Then the circuit will becomes a line impedance Z line in series with the load, right? Z load. So, and here the source also in delta form. Delta form means it is a line voltages. To convert line voltage into phase voltage, it means here two phase voltages. It means by adding to these two phase voltages, we will get the line voltage, right? It means VR minus of VY. It means just VR minus VY, right? We added VR plus minus VY. It will be result into VRY. Here, the angle between Vy and minus Vy is 180 degrees, right? This is 180 degrees and this is 120 degrees. So the remaining angle is 60 degrees. Here, Vr and Vy are balanced, right? The magnitude of Vr and Vy will be equal. So the angle between Vry and Vr is 30 degrees. It means the phase voltage lags the line voltage by 30 degrees. That's why to convert phase voltage, to convert the line voltage to phase voltage, we added just minus 30 degrees. So we got that phase voltage and we have Z line and Z load. So we simply applied the KVL in this equation, or just simply it's a Ohm's law. It is voltage by the impedance, total impedance, that is Z line plus Z load. We are moving to that next question. Next question is, in the figure given below, the RMS value of the line voltage is 208 volts. It is a line voltage 208 volts. Means RMS value is, line voltage is 208 volts. It is line voltage. Find the average power delivered to the load. Okay. We can convert into phase voltage. The phase voltage is PL by root 3, right? So 208 volts by root 3, which is of 120.0083 volts, which is RMS voltage. We can find out the current, right? Means here the line impedance is, Z line is 0. Is nothing is given, so we can study it is 0. So I phase equal to V phase by Z phase. Why? Because it is a balanced star load. So V phase equal to 120.083 by Z phase, it is 30 by 45 degrees, which is equal to 30 by 45 degrees, which is 4 point, I phase equal to 4.00 at an angle of minus 45 degrees ampere. We have phase current, we have phase voltage, so we can find out the average power. Average power is nothing but a active power. Active power equal to, it is a balanced source and balanced load. It is 3 into P phase I phase cos phi. So here 3 into, here V phase is 120.08 RMS value, and I phase is 4, its magnitude, it is RMS value, and cos of angle between V phase and I phase is minus 45 degrees. So which equal to 3 into 120.08 into 4 into cos 40 minus 45, which is equal to 1018.91 watts. We can write this is in kilowatts, which equal to 1.018 kilowatt. So the average power delivered by the source delivered to the load is 1.018 kilowatt, which is equal to 1.02 kilowatt. The option B. Here in this question he given the line voltage, so we converted into phase voltage. Here it is a phase voltage, so we calculated the phase current. So here the source and the load is a balanced, so the power equal to 3 into V phase I phase cos phi. Why? Because it is a balanced load and balanced source. So V phase we calculated and I phase we calculated. It is phi is the minus 45 degrees, the phase angle between voltage and current. which equal to 1018.91 watts. Its equivalent in kilowatt equal to 1.018 kilowatt. Approximately it is 1.02 kilowatt. Coming to the next question is a balanced three-phase star source. Means we can draw the circuit first. A balanced three-phase star circuit, star source. Sorry, right? This is, let us suppose A, B, and C. This is a balance. It is with the V phase equal to 210 volts RMS. VP means it is phase voltage. So it is 210 at an angle of 0 degree. VB equal to 210 at an angle of minus 120 degree. Why? Because it is a balanced source. He mentioned VC equal to 210 at an angle of minus 240 degrees. Right? And coming to the next part, a balanced three-phase star source with a PP equal to 210 volts RMS drives a star-connected three-phase load with a phase impedance of, means we can draw the source as well. Sorry, load as well. The load is, okay. Here we can consider it is ZA. Here we will consider ZB. Why? Because to connect easily. And here we consider ZC. So these are connected. Sorry. Okay. These are connected. Okay. Coming to the next question. ZA equal to 80 ohm. Z equal to 80 ohm. And ZB equal to 60 plus J90 ohm. 60 plus J90 ohm. 90, right? 90. 90 ohm. And ZC equal to minus J80 ohm. It's equal to minus J80 ohm. Okay. What is the next part? Calculate the complex power delivered to the load. Assume that the neutrals are connected. Here he given that the neutrals are connected. It means this point and this point is connected. So we can draw one line in between these 2 points. Okay, these two are connected. So here this circuit he seems like phase, right? It means this VA is having a closed path like this, right? And VB is having a closed path like this, and VC is having a closed path through the neutral like this, right? It means we can consider each phase and we will calculate the powers for each phase and we will add those things. First of all, complex power means is S. S equal to P plus JQ, which is known as a complex power, which is also known as a apparent power, which is equal to V into I conjugate, right? This is a complex power. So we know the voltage V. voltages VA and VB and VC. We don't know the currents IA, IB and IC. So first we will calculate the currents IA, IB and IC. So how can we calculate this current? This total voltage is applied across this ZA impedance, right? So we can find out the IA equal to VA by ZA, right? Why? Because this is a closed path. The total voltage VA is directly applied across this ZA terminals. So we can write IA equal to VA by ZA. What is the value of VA? VA is 210 at an angle of 0. Which is 210 at an angle of 0 by ZA is 80 ohm, right? Is equal to 210 by 80 ohm, 2.625 at an angle of 0 degree amperes. Similarly, we can write IB. IB equal to VB by ZB. VB equal to 210 at an angle of minus 120 degrees by ZB equal to 60 plus J90 ohm. 60 plus J90 ohm, which equal to 210 angle of minus 120 degrees by 60 plus 90 C, which equal to 1.9414 at an angle of minus 176.30. Yeah, one, we can stop up to this one, 3 degree ampere. Similarly, we can calculate IC. IC equal to VC by ZC, where VC equal to 210 at an angle of minus 240 degrees by, what is the value of ZC here? ZC is minus J80, right? This minus J80 ohm. Sorry, before, yeah, it is fine. What is the value this one? 210 at an angle of minus 240 by minus 80J, right? Which equal to 2.625 at an angle of minus 150 degree amperes. Okay, now we got the values of IA, IB and IC. What is the apparent power? We just told that V into I conjugate. So here we need apparent power for three phases. Apparent power for total three phase. So we can add all powers, right? Which is SA, apparent power of phase A, plus SB, apparent power of phase B, plus apparent power of phase C. This we can write VA into IA conjugate plus BB into IB conjugate plus VC into IC conjugate, right? So VA apparent power S equal to, I'm representing S3 phase with simply S. So S equal to VA, that is 210, right? 210 only, right? Yeah, 210. 210 at an angle of 0 degrees into IA. What is IA value? 2.625 at an angle of 0. What is IA conjugate? IA conjugate is 2.625 at an angle of minus 0, right? It simply conjugate means minus, right? So here IB conjugate equal to 1.9414 at an angle of plus, right? 176.3 degrees. Conjugate means only the sign will be vary. And IC conjugate is 2.625 at an angle of plus 150 degree. So we can write directly 2.625 at an angle of minus 0. 2.625 at an angle of minus 0 plus VB. VB is 210 at an angle of minus 120 degrees. And what about IB conjugate? IB conjugate value is 1.9414 at an angle of 176.3. 1.9414 at an angle of 176.3, right? Yeah, 176.3 degrees. And BC equal to 210 at an angle of minus 240 degrees into IC conjugate, which equal to 2.625 at an angle of 150 degrees, plus 150 or 150, right? So what is the value of 210 at an angle of 0? 210 at an angle of 0 into 2.625 at an angle of 0, which equal to 551.25 plus j 0, right? What about the next one? 210 at an angle of minus 120 degrees into 1.9414 at an angle of 176.3, which equal to, will represent some other different color. It is 226.2 plus J 339.18, right? Yeah. What about the third one? It is 210 at an angle of minus 240 degrees plus 2.625 at an angle of plus 150 degrees, right? Which equal to 0 minus j 551.25. It means the first one is the power due to the R phase, the second one is power from the Y phase, like A phase, B phase, and third one is power in the C phase. So we can add all these powers. So we will get S equal to, we are adding 551.25 plus 226.2 plus 339.18J minus 551.25J, which equal to 777.45 minus J 212.07, which is volt amperes. Okay, here why we calculate this one is, yeah, why we calculated like this is, first here a balanced three phase star connected Vp equal to 210 volts RMS. It is balanced three phase star connected load, and star connected ZA equal to 80 ohm and ZB equal to 60 plus J90 and ZC equal to J80. Okay, ZC is here J80, it's not minus J80. So sorry, it is J80. Yeah, it is J80. So where we, yeah, here it will be, where is it is G, it is J80. So 210 at an angle of minus 240 by 80 is J, which equal to 2.625 plus 30 degrees. Sorry, plus 30 degrees. So the conjugate will be minus, right? Just simply opposite, it is minus 30 degrees. So here it will be minus 30 degrees. So which equal to 210 shift at an angle of minus 240 into 2.625 shift at an angle of minus 30 degrees, which equal to 5. Here it will be plus. So this value will varies, which equal to 339.18 plus 551.25, which is 890.43, which is plus, which is option D. Okay, here these all loads are unbalanced loads. Why? Because the all are having different impedances. So we cannot write S equal to 3 into V phase I phase conjugate. Why? Because here these all are unbalanced loads. So we cannot write this S equal to 3 V phase I phase. We have to find out the S with each phase. The total S equal to S A phase plus S B phase plus SC phase. The to calculate that thing, SA, SB, SC, we need IA, IB, and IC. So we calculated IA, IB, and IC. We put in this equation and we got the total apparent power, which equal to 777.45 plus J89.43.